Hi and welcome to this talk called Future of Swift, a sneak peek at asynchronous. I'm Vincent and I'm talking to you from France, and as you can imagine from the title of the talk, we are going to talk about the exciting new feature that is soon going to come to Swift, the addition of async underweight to the language. But before we begin, a little word of caution. So, the content of this talk is going to be about a Swift feature that isn't yet officially released. And it means that all the code example I'm going to show you, well, they are still subject to changes by the time the feature is released. So if you are looking at this talk a few months in the future and asynchronous is now officially a part of Swift, well, please don't take all the content of this talk at face value and maybe take the time to check the documentation to make sure that what I'm saying is still accurate after the official release. That being said, let's get started. So what's the motivation behind this async await feature? Well, first we have to recognize that asynchronous code is what we could call the cornerstone of most iOS apps, because there are so many things in an iOS app that are asynchronous, and the most common use case is network call. If you try to make a network call in an iOS app, well, it's going to look something like this when you use Apple's API. So you're going to create a URL and then you're going to make your network call to this URL using the method dataTask of the class URL session. So of course this code is asynchronous in the sense that the result of the network call, well, when it will happen is something that cannot be predicted. It could be very fast, it could be a little bit longer. So the moment when we call this code and the moment when we have the result, they are not synchronized together. And the way that we deal with, we could say, this asynchronous code is through what is called a completion handler. So the completion handler is the closure that is passed to the method dataTask, and in this closure we are given as argument the result of the asynchronous code. So it's the data, the response, and the possible error returned by the network call, and in the closure we are going to use these elements. So this way of using completion handlers to implement asynchronous code, it's actually very popular in the iOS SDK, and there are some good reasons for it. First, Swift has a very good built-in support of closures. So when you need to pass in a closure, Swift has features like the trailing closure syntax that makes it very easy and very seamless to write this closure. And another good reason is also that closure, well, we could say that they are pretty easy to understand, especially when you are a beginner. You just need to make in your mind the link that you are passing a function that will deal with the result, and this function will be called at a later time once the result is available. And once you have understood this, well, that's it. You understand how asynchronous code works, and that's a good thing because it makes things easier for beginners. But also we can see that there is not a lot of abstractions, and this is going to become a problem, and we're going to see why. Because the issue is that while completion handlers, they have the advantage of being, we could say, very simple, they also have one big drawback, is that composing completion handlers is not a fun experience, because when you need to compose completion handler, meaning when you need to have several network calls happening one after the other, maybe because you need the result of the first one to make the second one, something like this. First, you make a call to get a user ID, and then using this user ID, you make another call to get some more information about the user, for instance, the first name and then the last name. Well, the naive way to compose this completion handler is by nesting them, meaning that we are going to make the second call in the completion handler of the first call. And we can see that this is not a good way to deal with code, because with every new call, we need to add a level of nesting. And so we could say, exponentially increasing the complexity of our code. And this is not what we want, because of course, if we need to make 6, 7, 8 network calls, the code is going to become unmanageable very fast. And actually, this is so bad that this situation even has some names. So some call it callback hell, some call it the pyramid of doom. And well, when a situation has such name, indeed it shows that it's not something desirable, it's not what we want to have in our code base. So how can we deal with this issue? Well, there are some solutions. So first, there is option one, is to use specialized libraries. And we actually have now some of them in iOS. So what we're going to do with this option is that we're going to use a set of APIs to basically, we could say, structure the way that we use closures. So this is how frameworks like Combine, RxSwift, PromiseKit, etc., this is how they work. So this is how the code looks like. So you can see that we still have asynchronous code, we still have closures, but we're not using, we could say, row completion handlers, we've introduced a little bit more abstractions. So for instance, when we need sequential calls, we use the function flatmap. When we need parallel calls, we use the function zip. When we want to consume the result, we use the function sync. So it's a better way of doing it, because now if we want to add a new sequential call, well, we're going to add a new call to flatmap, but we are no longer going to need to nest closures into one another. So it's a better way of dealing with asynchronous code, but we can see that there is still a little drawback, is that closures are still here. We are forcing them to behave through these new APIs like flatmap, zip, and sync. So it's better, but we could say, to introduce a lot of extra syntax. And this is where the second option comes into play. So the second option is to actually add some kind of built-in language support to deal with asynchronous code. And to see an example of it, we're going to see how the other guys are doing it. So I've put here what is an example of C# code, and this code is actually asynchronous, but you can see that there are no closure anywhere. But we can see that there are some keywords like async. The function main is marked as async, and we can see that whenever we are calling an async function, we use the keyword await. However, it seems here that we are somehow able to manipulate this asynchronous code just like some regular synchronous code. So it's a very interesting solution, and well, it's pretty cool. And what's nice is that this is exactly the feature that is coming to Swift in the near future. Because if you take a look at the Swift evolution proposal, you will find that there is indeed a proposal to add async await to Swift. And if you take a look at the header of this proposal, you will see that it is actually now implemented, and it's part of Swift 5.5, so the upcoming Swift release. So very interesting. And now the question is, can we get a preview of this feature in order to understand how it works before it is officially released? Well, the good thing is that yes, we can. It's pretty simple to do it actually. So how do we do it? First step is we need to download what is called the latest Swift snapshot. So basically kind of like a beta version of the Swift toolchain, we could say. So the way to do it is to go on the website of Swift, so swift.org, you go on the download page, and then you will see by scrolling that you have a part called trunk development, and you click on Xcode, and it will download a PKG file, which is the latest snapshot of the Swift toolchain. So once you have this file, you install it. Then you will need to set Xcode to use this new toolchain. So the way to do it in Xcode is that you open the preferences, you go on components, then you click on toolchains, and finally you select this development snapshot toolchain. Now, one thing important to note is that, of course, you are not allowed to submit an app to the App Store using this development toolchain. This is just for testing purposes and nothing more for now. And finally, you will need to enable in your project what is called the experimental features. So the way to do it is that in your project file, you're going to set a custom Swift flag. So in the build settings, you search for other Swift flags, and then you add this flag, so -x frontend -enable experimental concurrency. And once you have done this, well, you can now use async await, and the compiler will recognize it, and we build your code that uses this async await feature. So now we are ready, we can finally start experimenting with async await. So let's get back to our previous code. So this is the code that we had. We were not fully satisfied with this code, and we want to improve it. We want to use async await in order to deal with this asynchronous code. How are we going to do? Well, first thing, we are going to need to take our function, so here get user ID, get user first name, and get user last name, and we're going to need to turn them into async function in the sense of a function that uses the async keyword. So to do it, we're going to basically need to write a wrapper around our existing functions. So how are we going to do it? So this is the API that is exposed by our functions for the moment. So we can see we have this type alias to simplify the syntax a little bit, and then the function get user ID, well, it takes a completion handler, and this completion handler is going to return an int. And we want to take this code and turn it into an async function that uses the async keyword. So this is how the code is going to look like. And we're going to spend a little bit of time on this code because it's very important that we understand every part of it to really understand how the feature works. So first, let's focus on the signature of this new getUserID function. We can see that the function still returns an int, but whereas before it was returning this int through a completion handler, so through a function that was called and the int was given as its argument. Now the int is just the return value of the function. So the signature of the function, it almost looks like the signature of a classic basic synchronous function, except that we have added the keyword async. You see that async, we write it in the same place where we would write throws, for instance, so between the argument list and the arrow. And when the function is called async, it means that the function has the right inside it to use await. So await, we can see it once again, kind of like the keyword try. Await, it's meant to mark the call site of an async function. And when you call an async function using await, what's going to happen is that you're going to create what is called a suspend point, meaning that your function is going to block until the async function returns its value. So that's basically the key idea of async await in Swift, is that using await, we are dealing with asynchronous code just like if it were synchronous code, because we allow our function to suspend until the asynchronous code is done executing. And that's actually the magic behind it, is that if we allow our code the right to suspend its execution until asynchronous code is done executing, well, we get the ability to manipulate asynchronous code just like synchronous code. And of course, it will make our code much simpler to manipulate, because synchronous code, we know very well how to deal with it. So here you can see that in my function getUserID, I am calling an async function called with check continuation. And this function is very important because it is a function that is going to allow us to wrap existing asynchronous code that uses a completion handler into an async function that uses the new async keyword. And the way this function works is that when we call with check continuation, as I've said, since it is an async function, well, the function getUserID is going to be suspended, and the content of the closure passed to with check continuation will be executed. And we can see that this closure is given as an argument, an object called a continuation. And this object, it has only one method. It's a method called resume. We call it by giving it an argument. And what's going to happen is that once we call resume on the continuation, well, the method with check continuation will return, and it will return with the value that has been passed as an argument to the method resume. And this way, we are now able to take existing asynchronous code that uses a completion handler, call it in the function that we pass into with check continuation. In the completion handler of this asynchronous code, we call resume using the continuation, and this way, we are able to take this existing asynchronous code and wrap it in a new function that uses the new async feature of Swift. So that was a lot of new information, so we're going to recap it a little bit. So what's important to understand, as I've said, is that await, when you call an async function using await, you are creating a suspend point, meaning that you are going to block the execution of the calling function until the async function that has been called returns. And once it returns with a value, and you can use this value just like you would use the return value of a classic synchronous function. And this little trick, the nice thing with it is that, as I've just said, it allows us to now manipulate asynchronous functions just like if they were synchronous, and is going to help us a lot in managing the way that we call asynchronous code. But of course, as we can imagine, there is a trade-off, is that await can only be used in a function that is itself also async, meaning that an async function can only be called from another async function. And that makes a lot of sense, because when we are calling an async function, well, we create a suspend point, and we must be careful to only create these suspend points in places where it makes sense to create them. For instance, we don't want to create a suspend point on the main thread because it would block the UI and it would completely break the entire interest of the async await feature. So now that we have wrapped our first function, we are going to wrap the other two. So of course, it's going to be very similar, and you can see that the code is almost the same. Once again, the strategy is the same. We use with check continuation. In the closure passed with check continuation, we call the existing function, and in the completion handler of this existing function, we call resume on the continuation, and we pass as an argument the result that was retrieved by the existing asynchronous code. And now that we have this, so our three functions, we now have wrappers that now use the new async keyword, so we can call this new function and see what the new call site actually looks like. So this is what the new call site looks like, and we can see that it is indeed much better than the other call site, because this time we no longer need to nest code, to nest completion handlers into one another. Whenever we need to add a new call, a new asynchronous call, well, we just need to add a new line to our code, and of course, adding a new line to our code is much more manageable than adding a new level of nesting. However, if you remember what I've said earlier about the fact that we can only call an async function from another async function, well, you might be wondering, the function greetUser is marked as async. How are we actually going to call it? Because as I've said, an async function, you can only call it from another async function. And all the typical entry points that we have in iOS, method like application did finish launching with options or view did load, well, they are not async at all, and they're not going to become async. They are synchronous method. So how can we deal with it? Well, this is where a very useful attribute comes into play. So my function greetUser, I'm going to change it a little bit. It won't be async anymore. Instead, I'm going to decorate it with the attribute @async_handler. And we can see that this is kind of like a trade-off that is going to allow us to call these, we could say, top-level async functions. So what is this async_handler attribute? Well, the way that it works is that when a function is marked with @async_handler, this function can use await and call other async functions, and the function can also be called from any other function. So it's kind of like having the best of both worlds. Of course, this is going to come with a trade-off, with a limitation, and this limitation is that a function that is marked with @async_handler is not allowed to return a value. And the reason why is that when you call a function that is annotated with @async_handler, what's happening is that the execution of the function is actually going to happen on a background thread. So you call this function, it is, we could say, spawned into a background thread, the function is going to execute, and the calling function is also going to keep on executing. So there is no suspend point being created, and it is why you're not allowed to return a value, is because if the function were returning a value, well, there would be a need to create the mechanism to synchronize the return of the function to the caller. And of course, we don't want to have this because we want to spawn the execution of the function on the background thread. So we say a method marked with @async_handler is not allowed to return a value, but in exchange, it can be called from any other regular function. So for instance, we can call a method marked with @async_handler from the app delegate, from view did load, from any place of our Swift code. And if you actually want to try this, what you can do is that you can put a breakpoint in a function that is marked with @async_handler, and you will see that when the breakpoint is triggered, you see that even though you might have called the function from the main thread, well, the function won't be executed on the main thread. You will see on your call stack that you are on a background thread. So this is how the function now looks like. And it's already better than what we had before, but we could be thinking, can we keep on improving this code? And actually, we can keep on improving this code, because if we take a look, we can see something. We can see that, of course, we first need to make the call to get user ID, because we need to get the user ID. But then the call to get user first name and get user last name, here they happen sequentially, meaning that the call to get user first name must finish before we make the call to get user last name. But actually, it doesn't make really sense to have this sequential execution, because both calls, they need the same data, meaning that we could call in parallel get user first name and get user last name. And of course, it would save us time, it would make the app, well, work faster. So how can we do it? Well, this is where a new concept that comes with asynchrowait is going to come into play, and this concept is called asynclet. So asynclet is a new way to, we could say, declare a variable. So when we declare a variable with asynclet, we are allowed to initialize the variable using the call to an async function, but the function won't actually be called immediately. We can say that we are implicitly creating a task that will have to be executed a little bit later. So here what's happening is that when we use asynclet, we implicitly create tasks that will retrieve the first name and the last name. And then on the last line of the function, using await, we are executing the task and using the return value. And what's really nice is that the syntax that we have here makes it, we could say, very seamless, because we are implicitly creating a task hierarchy, but it's so seamless that it almost feels like magic, we could say. So a little bit of recap: when you use asynclet, what you are doing is that you are implicitly creating a task hierarchy. And then using await, you execute this hierarchy and you use the result that the task have yielded. And it's a very powerful mechanism because it allows us to, we could say, very shortly and very elegantly write asynchronous code that requires some, we could say, well, non-trivial synchronization, but we didn't have to write any code to synchronize the task by hand. It was very declarative, and the compiler was able to infer and generate all of this code for us. And if we compare this code with what we had when I showed the example using combine at the beginning, well, we can say that there is definitely a very stark contrast. And of course, the code we get using asynchroid, asynchronous, and asynclet, it feels much more elegant than the code we have when we implement the same thing using combine. However, we might be tempted to think that asynchroid is actually better than combine. And I want to say that it's not really the case, because combine is actually a much more general purpose tool to deal with asynchronous code. Basically, with combine, you can deal with any kind of data flow that is going to emit value over time. So you have to deal with things like data being updated over time. You can deal with things like back pressure, etc. It's a very generic tool. On the other hand, asynchroid, it's a much more specialized tool that is focused on a single use case. It's to be able to deal with calling asynchronous code that you want to execute either sequentially or in parallel. And of course, since it is focused on a single use case, well, it can be much more tailored to this use case. So that's also one thing I want you to take away from this talk, is that asynchroid is not better than combine. Combine is not going anywhere, I think. Asynchroid is just a very good way to deal with what we could call is the simplest use case with asynchronous code. But of course, when you get into more complex code, well, either you're going to want to use combine, or you're going to have to introduce some extra syntax in asynchroid, and of course the code won't be as seamless. That makes sense. And actually, to end this talk, that's what I want us to do. I want us to dig a little bit deeper to really understand what's happening behind this magic of using asynclet. And the way we're going to do it is that I'm going to introduce a new need. I'm going to say that, well, now we need to be able to cancel a task. So the call to get user first name, we want to be able to cancel it, because after all, when you create an asynchronous code, well, you need to have the possibility to cancel it. Think, for instance, that your asynchronous code is the upload of maybe some post to a social media app. Well, you want to have a cancel button in case the user wants to cancel the upload of the post. So what's interesting is that if we want to implement this cancel feature, we're going to have to explicitly create our task, and by doing it, well, we're going to see all the implicit code that was generated for us, and by seeing this code, we're going to understand what's happening behind the scenes, and it's going to be a great way to get a better feeling of what is behind the magic of using asynclet. So first, I'm going to remove the use of asynclet to get the last name, and I'm going to explicitly create a task by hand. So this is how it looks like. So you can see that now I've created what is called a task handle. So it's an object that basically is a reference, we could say, to the task, and using it, we can execute the task. So it's of type task handle, and it has two generic arguments. The first one is the return value of the task. So here it's a string because it's the return value of the method get user last name. And the second argument is the kind of error that can be thrown. And here it's a task cancellation error because it's the error that is thrown when you cancel a task. And you can see that I am creating my task using the method task run detached. So this is the method that I found for now to create a task. Remember, at the beginning of the talk, I was saying that the API might evolve by the time the feature is officially released, and I've kind of understood that the name of this method might change. So if you are listening to this talk once the feature is released, this code might no longer work, and you might need to take a look at the documentation to find out what is the correct way now to write this code. But for the moment, this is how you explicitly create a task. So now that you have created this task, well, you need to deal with it, because remember, before, using await, we could like very seamlessly execute the task and use its return value. But now it's no longer the case. We have explicitly created the task. We're also going to need to explicitly execute it and get its result. So the way to do it is that now we need to take our await code and we need to wrap it in a do block, because as we've said, we are going to add the possibility to cancel a task. So we need to have a do block to catch the error when the task is canceled. And you can see that now I cannot just use the last name handle, but I need to call the method get on it in order to execute the task and retrieve the value. And since this method can throw, because the task can be cancelled, I need to mark the call site with try. And then in my catch block, I need to deal with the error. Here, to keep things simple, I am just printing the error to the console. Then I'm going to actually add the code to potentially cancel the task. So here I'm just going to get a random boolean, and there is one chance out of two that I cancel the task. And finally, my task is going to need to opt in into the cancellation, because when you call cancel, you're not actually canceling the task. You are setting a flag that the task can check if it wants to cancel. So we could say that the cancel mechanism is an opt-in mechanism, and it makes sense because our task could be in the process of doing something critical, and we cannot, we could say, force kill our task. So the task need to agree to be cancelled, and the way that it does it is that the task is going to call the static method task.checkCancellation, and what happens is that if the cancel flag has been set by a code to the method cancel, then the call to task.checkCancellation is going to throw an error and is going to cancel the task. So this is how the code looks like when you need the ability to cancel a task. As I've said, we had to introduce a lot of explicit code. So all this business of creating a task and executing it before, it was done implicitly using asynclet. Now we have implemented it by hand. But the nice thing is that by doing so, now we have also a better idea of what's happening behind the scene. And we have an idea of basically what is the magic behind using asynclet. So we are reaching the end of this talk. I hope that now you have a better idea of what async await is. We have covered all the basic use case, so wrapping existing code in an async function, calling an async function, using the attribute @asynchandler to call the async function from existing non-async code, so all the entry points like view did load or application did finish launching with option. Then we've seen that using asynclet, we can actually create some very interesting and powerful task hierarchy in order to execute code both sequentially and in parallel. And finally, by introducing the need to cancel a task, we've seen what this actual task hierarchy looks like, and we've seen what is happening behind the scene when we use the very magical, we could say, asynclet. So to finish, I wanted to do a very quick recap and actually give you all the links that you can follow if you want to learn more on async await. So first, one sentence to recap this talk. So what we've seen in this talk is that async await is a language feature of Swift that is going to allow us to intuitively write and manipulate asynchronous code. If you need to remember one thing, it's this one. And then I want you also to remember that this talk was only an introduction on the topic, and there is a lot more to learn, and you have a lot of room to dig deeper in this topic. So I've put you the link. So the first one, it's a link to the Swift evolution proposal for the async await keyword. So if you take a look at it, you will see that it is more or less what we have covered in this talk. Then there is another evolution proposal, but this one is more dedicated to what is called structured concurrency. So it's all this idea of having a task hierarchy and using asynclet. And here I have not covered everything. And if you take a look at this proposal, you will see that there is a lot of detail and a lot of reflection on the part of the people that are implementing this feature into Swift. And then there is actually a third proposal about something that I haven't talked at all in this talk because it's a topic in and of itself. It's what's called actors, and it's the fact that, as we've seen, when we use async await, well, we introduce a lot of asynchronous code and a lot of parallel code in our app, and we know that a consequence of doing this is that we need to be very careful about the way that we access data. Otherwise, we can create some unexpected behavior with things like data races, etc. So actors, it's a proposal that introduces some new concepts in Swift that are going to allow us to, we could say, easily protect our code against this issue of parallel code messing with our data. So it's super interesting to read, and I can only encourage you to take a look at this proposal. Then I've put this link, so it's called the Swift Concurrency Roadmap, and it's a post on the Swift forum that basically gives you a big picture idea of what the people behind Swift have in mind when it comes to concurrency. So we could say it's kind of like a roadmap that puts together async await, structure concurrency, actors, etc. And then finally, I've put a link to what's called the Swift Concurrency Manifesto. And this document, it's more a document that says why the people behind Swift have chosen to go with async await. They explain why they think it's the right pattern, etc. It's a super interesting document to read, but it's also longer, and we could say it requires a little bit more of an effort to read, but still it's super interesting. So now it's the end of the talk for real. Thank you for listening to me. I hope you've learned something. I hope now async await is a little bit clearer in your mind. And most importantly, I hope you are as excited as I am to be able to use this feature once it is officially released. If you have enjoyed this talk and you want more content from me, so I've put 2 QR codes, you can go and follow my Twitter account, or you can go check out my YouTube channel. I have a lot of other content about Swift that you might enjoy. Thank you for watching this talk, and see you next time.